discuss about continuity of a function of single variable. That is, for a function y equal to f of x at x equal to a. For continuity of a function, we must have to get the functional value of f of x at x equal to a. That is, f of a must be defined. And f of x is said continuous at x equal to a if the limiting value, that is limit x tends to a f of x, and the functional value are same. Then we say that the function f of x is continuous at x equal to a, and we give this definition in another way as: for any positive epsilon greater than 0, this is no matter however small, if we find another positive delta greater than 0 such that mod of fx minus fa less than epsilon, this epsilon is pre-assigned because we first assign epsilon, any epsilon greater than 0, then we get, for this epsilon we get delta greater than 0. Mod of fx minus fa less than epsilon whenever for all x in mod x minus a less than delta, or we say 0 less than mod x minus a less than delta, then the function f of x is said to continuous at x equal to a, or we symbolically write limit x tends to a f of x is equal to f of a, and this is also called epsilon delta definition of limit. Okay, now we see this definition or this epsilon delta definition of continuity by a graph. We consider here this is x-axis and this is y-axis, and let this is a curve. Clearly it is continuous, and we take this point as x equal to a, and this is f of a, and here we choose pre-assigned number epsilon greater than 0. Then mod fx minus fa less than epsilon means fx lies between fa minus epsilon less than fa plus epsilon. Okay, and this is f of a, this line is y equal to f of a, and y equal to f of a minus epsilon, this means this is y equal to f of a, and this is y equal to f of a minus epsilon, and on the same length, the upper side, this is y equal to f of a plus epsilon. Now we clearly see that for f of a minus epsilon and f of a plus epsilon, the intersection are here and here. Okay, and maybe of same length from this and from this, or maybe of different length, and we choose delta such that if this is greater than this, then we take this part as the length of delta. Okay, and if we take this and this, because this is greater than this part, so this is a plus delta and this is a minus delta, and we say that, or we can write here, this is less than epsilon whenever mod of x minus a less than delta. So we get a delta greater than 0, for which if x in mod of x minus a less than delta, then mod of fx minus fa less than epsilon. So the function is continuous at x equal to a. And it is noticed that, must be noticed that, this is very important point of continuity. This value of delta depend on epsilon, because if we take epsilon is large, then fa minus epsilon is here and fa plus epsilon is also here. So it is clear that this and this are the line of a plus delta and a minus delta be same length on the left of f of a. Okay, so this delta. So if we take epsilon is large, then we get delta is also large. Okay, so we say that epsilon and delta are dependent. These two quantity are not independent quantity. These are must dependent to each other. Also, if we take x equal to a, if we take x equal to a here, take x equal to a here, not this is x equal to a, then there we get different value of delta by taking same value of epsilon, because the structure of curve here is different type. Okay, if we take the curve is like that, then we get this is and this is f of a and this is f of a minus epsilon and this is f of a plus epsilon, and we see that this and this delta is smaller than the previous delta. So epsilon delta are dependent. Also it is dependent on the point A. Okay, so this is the graphical representation of continuity. Now we take an important example to show by epsilon delta definition. Take fx as x square sine 1 by x, where x not equal to 0 and 0 for x equal to 0. And it is clear that f of 0 equal to 0. So we first start with fx minus f0, and this is x square sine 1 by x minus 0. Now from here we get this, and we know that this is equal to mod x square into mod sin 1 by x. Because greatest value of sin x or sin theta is 1, so we can write this mod x square, and this result is less than epsilon whenever mod x square less than epsilon. Okay, that is mod x less than root epsilon. Now we see that mod fx minus f0 less than epsilon whenever mod x less than root epsilon. That is mod x minus 0 is also less than root epsilon, and we take root epsilon is equal to delta. So clearly delta is depend on epsilon because delta equal to root epsilon. Okay, this is the epsilon delta definition of continuity, and this function is continuous. And if we want to prove continuity of a function f of x in the interval ab, in the closed interval ab, then we have to prove that the function is continuous at all c belongs to ab, that is interior of ab, and we have to show that at the point x equal to a, the function is continuous from the right because the interval start from a. So for this point we have to prove continuity from the right, that is we have to show limit x tends to a plus fx equal to fa, and also at the endpoint b we have to show the continuity at x equal to b from the left, that is limit x tends to b minus fx equal to fb, and then we say that the function fx is continuous in the interval I. This is closed interval a comma b, right? So this is the definition of continuity, and when or how we say a function is continuous in an interval, and the graphical representation of continuity with example. Okay, thank you. This is the today's class. Thank you for watching.